Hello, this is Bill Curtis, Executive Director of the Consortium for Information and Software Quality, presenting a seminar today on the cost of secure software development. And I want to tell you a little bit about CISC first. We were founded originally by the Software Engineering Institute at Carnegie Mellon University and the Object Management Group, and chartered to create automatable measures for measuring software productivity and quality. Over the last decade, we've produced 8 standards that are now available. They're free from our website or OMG's website. One of them has now been adopted as an ISO standard, the Automated Function Point Standard. We have others that have been submitted to ISO, in particular our standard for automated source code measurement of various software qualities, security, reliability, performance efficiency, and maintainability. So we continue on this work. We continue to work on developing standards for automating software measurement. We're working on one for the software bill of materials. Another project we're launching will be looking at measures for productivity and efficiency in an agile DevOps environment. We have one coming up for data protection, which will be a subset of our security measures. So we're engaged in continuing to try to help the field quantify itself with standards that can be adopted by vendors that are providing tools for doing these kinds of measurements. You can see our sponsors there on the screen. Those are the organizations that sponsor the work that CISC does. In particular, one of the sponsors you see there is the Center for Systems and Software Engineering at the University of Southern California, which is led by Dr. Barry Boehm. Many of you know Dr. Boehm as one of the founders of the field of software engineering. In fact, he was there at the original conference at Garmisch in Germany in 1968 when they coined the term software engineering and founded the field. Since then, Barry has been a leader in software engineering practice and research. Probably his best known work is the COCOMO cost estimation models, but there's a lot of other studies and important developments that he's been involved in over the last 40 to 50 years. So today he and his graduate student, Elaine Venson, are going to talk about their latest work on estimating the effort and cost required to insert security into software development. This is very timely, given that the Department of Defense in the U.S. is going to require all of its 300,000 suppliers and contractors to engage with the cybersecurity maturity model certification and become certified under that model. And one of the big questions involved in that work is, what is it going to cost for all these companies to become compliant with the security requirements in that certification? This seminar today is going to answer some of that. It's part of our fall series of seminars. In particular, I want to point out our Cyber Resilience Summit, which will have a lot of speakers from both government and industry on a lot of these topics on October 13th. But today we're going to be talking about the cost of adding security into software. So I want to turn the session now over to Dr. Boehm and soon to be Dr. Venson. Barry?
Okay, thanks, Bill. So as Bill mentioned, I'm the director of the USC Center for Systems and Software Engineering, and also the chief scientist of the DoD System Engineering Research Center. And as part of that research center, we have a 3-year project to try to do the best we can at quantifying all of the qualities that people get involved in both systems and software. So Elaine has been on this project for a couple of years and is making a good deal of progress on coming up with a model. And one of the things that we will be looking for is more and more data to calibrate the model. So as we go along, if you have anything, we'd be love to follow up with you on that. So At this point, I think I'll turn it over to Elaine. You ready, Elaine?
Yes, thank you, Dr. Boehm. Okay, so let's start. We all know that cybersecurity is a great issue nowadays, and software security is one aspect of it. So many security problems are rooted in the way we develop software. This chart, for example, shows that many of the problems we find in a study from the U.S. National Vulnerabilities, most of the most frequent errors are implementation errors like buffer overflow, cross-site scripting, SQL injections, and so on. And if we get only buffer errors, for example, that is showing in the most frequent in this chart, 93% of these errors involved only a single condition, typically a failure to check array bounds. So this shows that we have much to do in software development to help secure the softwares. This is the CyBOK, the cybersecurity body of knowledge. I'm bringing this today only to show how complex is the cybersecurity. It involves a lot of different areas and knowledge. But when we talk about software security, we are mostly focusing in these two areas, which is the software security and secure software lifecycle. Software security is about the categories of programming errors and resulting in bugs, and the techniques we can use to prevent and avoid this kind of errors that lead to vulnerabilities. And software lifecycle is the application of secure software engineering techniques in the whole life cycle. So the resulting software is going to be secure by default and easier to protect in the environment. So this is the touch points, is one example of a secure software development life cycle. And we can see that it includes practices to prevent and detect vulnerabilities all over the development process. So for example, when we talk about requirements, we can see we can develop abuse case, abuser stories, security requirements. During architecture and design, we can do risk analysis, risk-based security tests, code reviews, code inspection, or use tools to do static analysis tools, for example, to review the code. During tests and results, we can do penetration testing. And of course, during operation, there has to be a feedback from the field to improve the process and implement the lessons learned. So what we are going to discuss today first is how can we see the secure software development as a the cost effectiveness of these practices in software development. Also, then we are going to discuss about the sources of cost in secure software development, and we have two main components: the security practices and the security controls or security features. Next, I'm going to talk a little bit about the survey we did with practitioners about how they apply these practices. And then I'm going to talk also about the existing models we have for cost in secure software development. And we'll see that we have some issues that we have to improve in these models so that we can apply them more successfully. And then the next steps we're doing in this research. So we can see software security as a trade-off. There are advantages and disadvantages in doing more or less security. So if you do more security, we're going to have more costs on personal expertise, on installing and using tools, training everyone, improving process as we receive feedback from the operation area. And also the investment is done in early phases of software development. But as benefits, we can prevent and detect vulnerabilities before the software goes to operation, and we avoid many risks this way. On the other hand, if we do a little less security, we can have higher costs in fixing the software after it is delivered, patching these vulnerabilities. We may have downtime if the software is attacked, and then we'll have recovery costs and reputation loss, for example. But there are some benefits because we can give more priority to features, and we can have a better time to market. So we need to balance this both aspects depending on the risks and the software we are developing. We need to achieve this balance. We don't want to overdo security. So in this chart, we have the security production, which would be which will have the inputs, the costs, output, the benefits. It is decomposed using the security level. So if you see here, the dashed lines are the benefits, how the benefits grow according to the security level. And in the solid lines, we have how the costs grows according to the security level. So we can see that at some point, the cost of doing security will be higher than the cost of recovering from an attack, for example. But to do this kind of analysis, we need to have information about costs and about benefits and which security level we need in the software. And unfortunately, we don't have much of this information to support the decision makers in software development. So we started by trying to find out which are these costs and how we can measure these costs. And we did a really extensive literature review and trying to find as many information as we could about these sources of costs. And we found that, so we searched in this material, all related material to software security that discuss the cost, effort, and budget. This table shows how we classify, a summary of how we classify the sources of cost. So we can see that most cited source was perform security review, then apply threat modeling, perform security testing, apply security requirements, apply security tooling. So all these cells in this table, which are orange, they are related to security practice, these activities that we do during the software development. And the gray cells are other sources of vulnerability, like implement countermeasures, can be, it's a general aspect, can be implementing a security feature or applying a practice as well. Fix vulnerabilities, which also is not a practice per se, but it's a cost when we need to fix these vulnerabilities, and so on. So we classify this, and we realize that most of these sources that we found, which are these orange ones, are really related to software practice. So we need to look into this aspect. And when we see, when we look how software, what we have in software, secure software development, we can represent this cost breaking down from the goals, which are to build in security to preserve the assets and guarantee confidentiality, integrity, and availability. So these are the goals. But how can we achieve these goals? So there are two aspects in the requirements. We see that are functional aspects in security when we define and select features, controls, or components that will be developed to protect the software. For example, authentication, authorization, audit, cryptography. So all these components that are going to be developed. And these components we can measure then in lines of code or in function points, any size measure that we can use to measure the software. On the other hand, we also have a non-functional aspect of security. So in this part, we include these security practices that I was mentioned before, like threat modeling, pen testing. So any constraints that we are going to apply over the features, we can classify in this as a non-functional or quality that we want the software to have. And how can, these are really challenging to measure. So we propose to develop a scale where we can define levels of application for these practices, considering the scope and the rigor that we are applying these practices. So a second step in analyzing all these costs and these practices was to understand how these were applied in the industry. And then we did a survey with participants of the software security group on LinkedIn, and we obtained 110 responses from 29 different countries, but most of the people at around 30% were from the US, then 15% from India, and then we have countries of Europe and other continents as well. And in our sample, we have 30% of security experts, 16% in a management position, 16% software developers, 12% project leaders in development, 5% members of the security group, 1% testers, security testers, and 13% others. So when we found, for example, that apply secure coding standards was the most frequent practice for these people, and more than 50% apply this practice daily. Then we have also apply security tooling, static analysis tools or dynamic analysis tools, track vulnerabilities, which is to detect, track the vulnerabilities, detect and prioritize their solution, apply security requirements, so specify, analyze these requirements, perform security testing, then improve software development, which is to apply the lessons learned from the operations and try to avoid that these problems happen again. Document technical stack also used. So we need to document which components we have in the product and to track if we need to do patch and so on. Perform security review, apply threat modeling, apply data classification scheme to document the sensitive data, perform penetration testing, publish operations guide because many problems occur because the configuration of the software is not correct in the operations environment, and perform security training. Okay, so now let's do a poll to see how the audience, if you apply these security practices. I think it
great.
And, yeah.
And this is Tracy with Fisk. I'm going to help out with the polling and Q&A. Since there's quite a few options to choose from, we're going to shoot this out as a couple polls, but let me open the first. So which security practices does your organization apply during development? Here's the first set of responses. We'll leave this open to collect, and we'll share once we get through the remainder. Great, poll in progress. Let's give it another 10 seconds. Okay, now on to the next, and then we'll show all these. So the next batch, which security practices does your organization apply during development? Ten more seconds, and then we'll go to the final. My 10 seconds are faster than others. Okay, so the third part. There's 3 remaining security practices: security training, data classification scheme, and publish operations guide. Okay, looks like we got all the votes in. So now, Elaine, would you like to take a look at the results?
Yeah. Can you display the results, Tracy?
I can. So here from the first page.
Okay, yeah, we have security requirements and security testing, 78%. Yeah, that's very interesting. It's interesting because security requirements, in many cases, people don't do this formally, but yeah, this is a very first step, important to have security and be able to track down during development. Then we have secure coding standards, 67%. Security tooling, also it's an important resource to have, and track vulnerabilities. Okay, yeah, interesting result that security testing, yeah, very high numbers. So the next we have security review, yeah, code inspection. We can do also security review using the tool, so there is a kind of overlap in these 2 practices. And yeah, we have penetration testing with 55%. Yeah, what we have seen many people discussing is that sometimes penetration testing, which is a expensive resource, is used to get like vulnerabilities that could be easily resolved doing security review or using tools, for example. Then we have developed process improvement with 52%, which is very good. And then document technical stack. And threat modeling, yeah, threat modeling, I guess it's done in projects with more a higher need of security. So in the last one, we have security training, 68%, data classification scheme, 43%, and operations guide. Yeah, this result is similar that we had. So operations guide is not treated as important as the other practices. Okay, thank you everyone for the participation. I think we can go ahead and, okay. So another result we got from the survey is we asked people to say how much of the total effort of the application is that so they selected one application to answer the questions in the survey, and we asked in that application how much effort was dedicated to security. And then we did this chart by development type, and we see that the numbers have a huge variation. So in new development, we have this average of 25% of effort dedicated to security. In enhancement, we had an average of 40% of the effort dedicated to security. Migration, around 38%, redevelopment, around 20%, and also others. But we see that the maximum value and some outliers, and the range is very high of how much each project dedicates to security. And we asked people what were the challenges in estimating and planning security practice. And we can see that this is a very cultural thing. So the first one said, getting people to truly stop and understand 100% why the best practices are needed can be a challenge. When people get focused on delivery dates, once you explain what could happen, it tends to sink in. The other one, another one, convincing project manager to incorporate security-related time and effort. Another, always people considered security as feature to add after business logic and programming are finished. So it happens to delay the project a lot. So as we had many security experts in the sample, we see that they have a hard time trying to convince project manager or even developers that security is important. So having a tool that can help define how much security is needed according to the risks of the project and characteristics of the project is an important thing to have. And then let's do just one more poll regarding how your organization estimate the effort. So we have this option, so ad hoc, expert opinion, analogy-based, model parametric like COCOMO, other model of, it doesn't apply to your case.
Okay, let's see. Leaving the poll open for a couple more seconds. Any last minute votes? Still going up. How is effort for software security estimated in your organization? Okay, looks like we can close and share the results.
Thank you, Tracy. So we have 38% with expert opinion, 31% model or parametric, 13% analogy-based, and ad hoc. Yeah, that's an interesting result. In our survey with the experts on LinkedIn, so expert opinion had the most frequent technique used. So that's interesting that we have here many people using model parametric, but we'll see next that the current models we have, they're not, they don't have, or they have some issues that we can improve on them. So yeah, that's an interesting result. Okay, thank you, Tracy. Okay, so going next, we're going, oops, okay. So next, let's talk about a little bit about this models that we have for costing secure software development. So in that mapping that we did on the literature, we found actually 10 approaches to estimating costs of software security, but 5 of them have a very restrict scope. So these 5 were the models that could represent the whole software development lifecycle. So the first one in 2003, we have the COCOMO 2 security extension. So this extension was created because of the need to also to evaluate the COTS components that started to be introduced in the projects, and as they came from third parties, it was important to assess the security. So this extension was created, and we see that we have this these values here. Additional cost are in this column. These values are the multipliers that we would use to represent the increase in the cost due to security. And you can see the productivity range in this case was 1.85. The source of these numbers are expert estimation, and the model was not validated with real projects data. The second proposed model was COSECMO in 2008, and we have a very large productivity range, because they used 2 inputs provided by a commercial company and also expert estimation, but also we unfortunately couldn't validate this model. And then in 2014, weapon system cost model was developed, was proposed in the context of South Korea defense. And they found this only 2 levels, lower, nominal, and high, but this range of 1.87. They use expert estimation and 73 data points and did a cross validation using this, the security cost driver, and also other cost drivers that they found for defense systems. And then in 2015, we have this model, a secure operating system software cost model, also a COCOMO 2 based model, but they adapted to Chinese security standards, and they found this productivity range of 3.75. And this was found through expert estimation, and they did a case study of one secure open operating system to validate this proposed model. And we had some studies on function points, if-bug function points, proposing a security extension, but you can see that this is very limited. It increased only 0 to 5% in function point size of the project. And it was based on a practice from a survey with developers, and unfortunately not validated. So here we can see these same models. If we compare their numbers, we can see that, for example, for going from nominal to high, it can be a 20% additional cost. It can be 80%. So we have high variations. And if we go in the higher levels, very high, extra high, super high, these variations becomes very, very large. In this chart, with excluded the cosecmo max, which is an outlier in this case, and we focus on low to super high levels. And we can see that going from nominal to high, for example, as I mentioned, can be very different from one model to another. If you go to very high, for example, you can double the effort, or you can just add 40%. So this can be done because we have expert opinions only, basically. We didn't do any validation to check, to assess these models if these are realistic. So most of these models, they use the common criteria evaluation assurance levels to define these levels. And they don't discuss in these models, in these papers, they don't discuss much this mapping and this rating from practitioners to select the appropriate level. And also, but this represents some problem because many developers, they don't use this standard. This is an important standard, but it is mainly focused on product certification. It is used for security benchmark of ID products. The certification is expensive and take time. The levels are defined around the depth and rigor of design, tests, and review of security features. So the standard, it has a catalog of the security features, and these levels are the levels we use to assess if these features are implemented or not, and the rigor that we do this assessment. So it was not specifically developed for secure software development in general. So this is an opportunity to develop a rating scale based on security practices, because we saw that nowadays we have many options of security practices that teams do during software development process, and some of these are not covered in the common criteria standard. Also, we have these opportunities for validation of the model. So no model has been properly validated with industry data. And there is now the COCOMO 3 initiative to collect data from industry. So this is an opportunity to try to validate this cost driver for security. Another opportunity is to use open source software repositories. So we can see, and there are many studies showing that nowadays the open source development has many similar characteristics with closed source software development, and having access to the code and to developers, we have one more source that we can use to evaluate this, the additional cost of security and the additional size of security, for example. And also it is important to have the involvement of the communities of security experts and estimation experts. Sometimes these Delphi sessions and these opinions are collected only for estimation experts. It's important to involve these two communities. So next steps, what we are doing. So we are doing this developing a scale for measuring the level of application of security practices. So we got these practices from models used in the industry, like the touch points that I showed, the Microsoft WASP model as well. And so all these practices, we analyze how we could aggregate these practices that are being used in one scale, and we are testing this scale to be used to measure the level of secure software development. And in parallel, we are modeling using the COCOMO modeling methodology to create a model that we can apply this scale and try to validate this security cost driver. So using that model that I showed before, so we have these two sides, the functional and non-functional. We want to reflect these both lines in the model. So we have this CQ cost driver, which will reflect these levels of application of security practice as a multiplier. And on the other hand, on the size component of the model, we want to consider the security features size. So, and we can do this in two ways. For example, we can estimate the security feature size, or we can use a size factor, security size factor, to estimate the size, the security size, and apply to the total size of the application. So this is what we are trying to do. And we are collecting data from security experts, estimation experts, doing wideband Delphi. So we are currently doing a online with security experts and trying to get their opinion and discuss together the rating scale that we are proposing. So we are getting this their input and improving this is rating scale that we are proposing as well. Also, we're getting data from industry, so projects data. It's a manual data collection form that we ask people to provide. And on open source software, we are extracting data from the repository, so we can some part of this data we can extract automatically using the APIs of the repositories, but we need to complement that data collection with inputs from the developers. So we're also doing a survey to collect this additional data. And then the next step is to evaluate. So evaluate the security rating scale. So how reliable is this rating scale? The validity, which is the ability to measure the latent variable of security. And then the effect of security on software development. So the significance of the coefficient for security, the goodness of fit of the model, and also the model accuracy. So yeah, that's it. I think we are inviting everyone to participate. So if you're interested in participating in an Delphi study to analyze the rating scale and share your estimates, you can do that anonymously and see the results of other expert as well. So you can compare and help us get this data. And also important to, if you can provide data for us to validate these models, you can provide sanitized data. And then after we do this analysis, we can provide you with the version of the model calibrated from your organization. So if you can participate, if you can help us, you can contact me, or also you can contact Brad Clark, which is the project coordinator of COCOMO 3, and he is managing all data received from project. Okay, I think Tracy is sharing now the poll, right? So yeah, just click and provide our information if you want to get involved.
Exactly. So this is just another way. If you want to select one of these options, what we'll do is we'll give your email contact to Elaine and team for next steps on the study and data collection. So we'll leave this open for a few moments.
And yeah, while people voting, and just would like to comment that in the Cyber Resilience Summit, we're going to present more about this rating scale and these results we are getting from experts. So if you are interested, you can go and watch the presentation, which will be basically a continuation of this presentation.
Excellent, thanks. I'll close this. Oh, we just got another vote. Okay, great. And it looks like about a quarter of attendees had marked something, so that's great. Thanks, everybody.
Yeah, thank you, everybody. All the help will be welcome.
Will be very valuable data for us.
And if you're ready, we're starting to get some questions for Q&A.
Okay.
All right, let me pop this open. Is the SciBoc available for reference?
Yes, the SciBoc is an open, and it's an open reference. You can, I think in the slides we have the URL. I think it's available on the handouts, right, Tracy? People can download this presentation.
Yes, yes, and if there was a link, so the handouts tab in GoToWebinar, we've gone ahead and uploaded a copy of the slides from today. So there'll be a link to the SciBoc there.
Yes.
And another question, security features and implementation can be different depending upon the type of application. How does the proposed model deal with this?
Yeah, so there are previous research showing that the domain can be an important variable driver in this model. So we're planning to have at least these three domains: information systems domain, engineering domain, and real-time system domain. So of course it will depend on the data we get, but we're going to analyze this effort in this, at least in these three different domains.
Great, thank you. Question in the questions box. What standards are referenced and used in developing the standard?
I'm not sure which standard are you referring to? So if you're talking about the SciBoc, so there are many different areas and they refer to many different standards because it's more of a knowledge areas. So there are many different standards depending on the area that it is. So, and there is a diverse group of people involved in this initiative as well.
Yes, and thank you. I think it was referring to the SciBoc. The question was right underneath the first question about SciBoc. And meanwhile, okay, now we have a whole pipeline of questions. The security factors appear to be linear on the slides. Is this validated? Could they be exponential?
Yes, they are not. Yeah, they are. It's a multiplier, so we expect to grow linear with size. But it's not. The factor is not linear because we have a nominal, high level. So in these levels, the factor grows exponentially. But the multiplier, it's applied. It's a multiplier on the size. So in the model, we have the exponents on size, which represent economies or diseconomies of scales. But yeah, depending on the model, the modeling step will give this answer. So initially we think that this will be a multiplier, but depending on the data, on how we model it, we can evaluate if it can be an exponent on the grows exponentially on size or not.
And are you looking at security impacts on either software maintenance or sustainment efforts?
So at this point, we're initially looking on software and new development. But again, it depends on the effort, on the data we get. So maintenance can be a little different of new development. So initially we're focusing on new development.
Okay, thank you. On slide 29, you mentioned the security size factor. How is this factor defined?
So for defining this security size factor, we're doing some studies using open source. We are getting this project, classifying the files in if they implement a security feature or not. And according to the security level, we're trying to find this proportion of security features on the code. And also we are going to try to collect this information from the industry, projects from industry as well. So then we have the intention to have this proportion in the security size factor.
Okay, so I'm going to invite Dr. Bill Curtis back, and if there's some more questions, feel free. I know Bill is just going to take a moment from CIS just to thank Dr. Boehm and Elaine. And there's a question here. The common criteria offered in international standards for evaluated products, is there a drive for an international cybersecurity standard for software development? And actually, CIS could speak to that as well. Bill, are you back on?
Yeah, I'm here. Yes. There are international standards. There's ISO standards for cybersecurity and for secure facilities. And so I'd refer you to those. I think 27001 would be one related to creating secure software and having a secure facility. CISC has created a measure for measuring the security attributes of a piece of code by looking at the common weaknesses, the severe common weaknesses that are in the code. We developed that from the CWE SANS Institute Top 25 and the OWASP Top 10, plus other common weaknesses that were considered severe. So that's a good measure. It would be, you'd use static analysis to detect that, and several of the vendors of static analysis technologies are now implementing that measure. Frankly, security from a code point of view, security is the hardest one to evaluate. The vendors are finding it harder to implement the analysis capabilities to determine whether you have security vulnerabilities because of data flow and other very specific capabilities you have to analyze it. So, but that field is developing, and there are some very good analysis tools out there, and many of them are implementing the CIS standard for automated source code security measure. I want to thank Elaine and Dr. Boehm for their presentation today. I encourage you to look at some of the other research outputs and reports and that are being developed by the Center for Software and our Systems and Software Engineering at the University of Southern California. And in addition, I would also encourage you to go to the CISC website. You can see it there. Now, you can join CISC for free. A membership is free because our work is funded by the sponsors you saw on the earlier slide. But we now have over 3,000 members. In fact, we're approaching 4,000. I think we're over 200 organizations that these people come from. You can see a number of the organizations represented. So, this is the Fortune 1,000 type corporations, actually Fortune 200 in many cases. But we encourage you to go to CISC and the website. You'll be asked several questions, then Tracy will send you a password. In the website, we have all the standards that CISC has produced through OMG, and the ones that are also going through approval at ISO. In addition to blogs and all the presentations from our various webinars and cybersecurity summits are there. So there's a number of resources that you can draw down. We're trying to make the website as a go-to place for information about the quality of IT and embedded systems from both the code and the architectural system level. So I encourage you to go and join this community and participate. You can contribute blogs and other kinds of things. So again, I want to thank Dr. Boehm and Elaine Venson for today's webinar. It's very timely since this is an increasing concern both in government and in corporate IT departments. So worrying about the cost and what it takes and where the right trade-off points are is becoming a critical decision point for a lot of people involved in system and software development. So thank you, and we look forward to seeing you again on future CISC webinars and our Cyber Resilience Summit, which will be on October 13th. Thank you and goodbye.
One more thing from Barry.
Barry, yes.
We're having our 35th annual Kokomo Forum on October 26th and 27th, Monday and a Tuesday, and feel free to follow up with us, and we'll keep you informed about if you want to submit something to the forum or you want to come or be tuned in. Coming is again going to be virtual.
Excellent.
Great, and we can help you with that too, Dr. Boehm. This is Tracy from CISC. What we'll do is we'll send a note to everyone after this webinar. Here's the link to the recording, the slides, the standards, and we can point out the Kokomo conference coming up. So great. Okay. Well, thanks, everybody. Have a great rest of the day.
Okay, thank you.
Goodbye.
Bye, everybody. Thanks, Elaine. That was really good.